Hello everyone, and welcome back to another R tutorial video. And in this tutorial video, we're going to give another example of how we can include multiple graphs on a single plot. And this time, we're going to do something that you will oftentimes see done, where you have a set of points and then you have the trend line, or the line of best fit for those points on a single graph. And we're actually going to take it a step further, and we're going to do two sets of points and two lines of best fit, just to sort of reiterate some of the concepts we've talked about before. So what I've done here is I've actually done a little bit of upfront housekeeping. I would expect you to probably be able to understand what this is doing here. This is just sort of pulling out and subsetting the data like we've done before. All of this stuff here isn't really necessary for you to understand what each line of code is doing, but essentially what I've done is I've generated a set of x and y coordinates for the trend line. And this will make a lot more sense when we pull everything together. So what I want to do this time is I actually want to start with base R and build everything up, and then show you how you get the same effect in ggplot. So as I mentioned before, what we want to do is we want to have two sets of data, the setosa data and the versicolor data, those points plotted out, and then have their trend lines included as well. So the first thing we're going to do is we're going to plot, like we always do, our setosa. So we're going to include the formula, and then we're going to do I underscore setosa $, and we're going to do sepal width, the tilde here, and then I underscore setosa sepal length. So this is going to create a plot with sepal width on the y and sepal length on the x. So rather than go through and show you the sort of mistakes we made in the previous video talking about how we have to deal with stuff in base R, I'm going to jump right ahead and make the plot look mostly nice up front. And the way we need to do that is we need to consider the fact that when we start to add additional layers, we have to make sure that the original plot is the proper dimensions in terms of x and y. So what I'm going to do here is I'm going to do xlim equals, and I've already kind of played around with this, so I know that a value of 4 and a value of 8 is going to give us plenty of space for everything to fit on the plot. And the same thing with the ylim. We're going to use a value of 2 and a value of 5. Now again, this xlim and ylim, I kind of already played around to figure that out. But again, if we didn't have this and we start adding layers, we're going to start cutting things off when we start adding the second data set. So this will give us the first data set. And then if we want to add the second one, we do that with the points function. And the points function is going to take in a formula, and we're going to do I ver $, sepal width, and then we're going to do for the x-axis I underscore ver $, sepal length. So what I want to do is I want to just run these two just to show you that we do in fact have two different sets of points. We can't differentiate between them right now because we haven't gone back and changed colors or anything like that. But for now, we have both the points. The next thing is going to be adding in the trend line. And as I mentioned before, I don't expect you to understand what these codes up here did. Just note that the way that we're going to approach this is by using the lines command. And what the lines function does is it takes in x's and y's, and it will create a line that connects all of the points in x and y. So what I went ahead and did up here is I created a min and max record for x and a min and max y for the trend line of x. So if we do setosa first and we set this equal to x underscore setosa, and we set this equal to y underscore setosa, and we run this line of code, and then we rerun plot, and line, you'll see that we've created a trend line here that goes from the start of the Setosa dataset to the end of the Setosa dataset. And again, this up here, if you're really interested, you can read through the code. But really what's important here is that to add in a trend line, we give it the start set of x coordinates and the end x coordinate, and the start y coordinate and the end y coordinate. Now we can do the same thing here with the versacolor by adding in the versa set of x and the versa set of y's. So if I run all of this again, plot, points, line, line, you'll see that we've basically got what we want. We just need to make it look a little bit better. And the way we do that is we go back into each of these calls and we set up the sort of aesthetic parameters. So the first one is going to be to make the Setosa points look how we want. And I always like to differentiate things in black and white whenever possible and use shape. So I'm actually going to set this equal to 16, which is the circle. And then I'm going to use the color. And then I like to use RGB for this because I can simply do something like 0.5, 0.5, and 0.5. And what this is going to do is this is going to make the Setosa, I can just quickly run this and show you what it will do. It's going to make the Setosa gray circles. Now for the versacolor, what we can do is we can make them equal to 17, which are the triangles, and we can do call equals, and then we'll do RGB. And then I will do 0.25, 0.25, 0.25, which is going to be a darker color gray. So if we run that, run plot, run points, you'll see now that we have gray circles and darker gray triangles. Now we can differentiate the points. For the lines, what we can do is we can do the color to match the points. So we would do, I'm going to copy and paste here so I don't make mistakes. For Setosa, we can do 0.5, 0.5, 0.5. And then for versacolor, we can do 0.25, 0.25, 0.25. And then what I like to do is I like to change the line type, so LTY. Now this works just like PCH does, where there are an underlying set of numeric indices, and you feel free to look those up later, and I'll have a link in the description. But the line type that we're going to use here is 2, which is a nice dashed line. So now if we run all this code again, and we go plot, points, first line, second line, you'll see that we have now created the look we want. Now all we have to do is add a legend. And to sort of recap how that works, we use the legend command. Inside of legend, we have to give it a legend. And again, these are the sort of things that it's going to use in the legend, and we're going to pass in Setosa, and we're going to pass in versacolor. We also have to pass in the location, which actually I like to start with that. So where do we want to put it? And we're going to put it in the top right. And then finally, we have to pass in all of the aesthetic parameters that we want to use. So I would prefer to do the PCH of 16 for Setosa and 17 for versacolor. And then finally, what color we want to make those. We want those to be, and I'm going to copy these so I don't make a mistake here. The Setosa was 0.5 across the board, and the Versa color was 0.25 across the board. And you'll notice how both of these are inside of this vector here. So if we run this, and then we go back, we got to rerun everything because of, for some reason, it's not doing what I would like it to. Lines, lines, and then finally legend. So you'll see that what we've managed to do is we've managed to add 4 data sets on the same plot, where we have 2 different point data sets and their trend lines, and a legend that differentiates between them. Hopefully that makes sense. If you have any questions or you seem confused about anything, I encourage you to pause, go back, rewatch the parts you're confused about, and as always, please reach out. Thank you.